Hello guys, today we're going to study 3.4 zeros of polynomial functions. Here we have the rational zero theorem. Possible rational zeros is just the factors of the constant term over the factors of the leading coefficient. So from the example 1, we look at this function. That is our constant term. So our leading coefficient in this case is just -1 because here it's invisible. Okay. Now we want to list all possible rational zeros. Here we have a constant 4, so the factors we're going to have positive, -1. We also will know it's an even number. Definitely we also have positive, -2. So then another one that will be factor is the positive, -4. And then we look at the leading coefficient, it's just -1. So we're going to write our factors, it's just going to be positive, -1. We're going to separate each term, so we're going to have positive, -1 over positive, -1, positive, -2 over positive, -1. Since we're doing the first example, I'm going to show you guys step by step. That will be positive, -1. The second term that will be positive, -2, and then we'll have positive, -4. So that will be our 6 possible rational zeros. So we're done with this question. Okay, let's try another one. Example 2. Again, we're going to start with finding the leading coefficient. Okay, that's 15. I'm not going to write the whole thing, okay? And then we also have the constant term. And then we're going to list all the possible rational zeros. We're going to write it as equal to the factor of the constant, the -2. We're going to have -1, -2. For our factor of leading coefficient, we're going to have positive, -1. We're also going to have positive, -3 because 2 wouldn't work. And then we have positive, -5, positive, -15. So once we have this, again, you just separate them. So then we're going to have, alright, we're just going to simplify it. I'm not going to write step by step. Positive, -1, positive, -2, positive, -1 over 3, positive, -2 over 3, positive, -1 over 5, positive, -2 over 5, positive, -1 over 15, and then positive, -2 over 15. That's total 16 possible rational zeros, which is listed above right there. That's your answer. Example 3 is finding zeros of a polynomial function. We have f of x equal to x third power plus 2x squared minus 5x minus 6. So first of all, we're going to find all the possible rational zeros, just like earlier we did. Alright, once you have step 1, you find all the possible rational zeros. Step 2, we're going to use synthetic division to find a zero from all these possible rational zeros. Alright, in this case we have 8 of them. If f of x is divided by x minus c and the remainder is 0, then c is 0 of f. So in this case, let's try a couple of them. So we're going to try one first. So we already know how to do synthetic division. So we're going to have, here we're going to have 1, 2, -5, and -6. That's just the coefficient. So we're going to have drop this 1 down, and then we multiply this, give you 1, and then you add those. You're going to have 3, multiply again, that is 3. So here we have 3, we add them, -2, and then again multiply, that will give you -2, you add them, give you -8. So clearly in this case our remainder is not 0, which means this 1 is not a 0 of f. So the second one, we'll try 2. So we're going to have again is 1, 2, -5, and -6. Drop it down. They're going to have 1. This have 2. Then add them to 4, and then this multiplies to 8. Add them. That will be 3. Multiply to 6, and then we'll add them. Give you 0. So that means here, right? This is remainder is 0. The remainder is 0. That means the 2 is a 0 of f. That implies x minus 2, that's the form x minus c, x minus 2 is a factor of f, right? So we're going to rewrite this function as the equation. So that will be x cubed plus 2x squared minus 5x minus 6 equals 0. So because we know x minus 2 is a factor, we're going to write x minus 2 is a factor of f. So then we're going to use here, okay, that is the standard deviation. That's your remainder. This is your constant. So your constant is 3. So I'm going to write constant as 3, and then this is your x term. So that will be 4x, and this is the front. That will be x squared. Alright, we're going to have x squared plus 4x plus 3, and then equal to 0. So that is where that comes from. X minus 2 is come from here. Once we have this, we can factor this as x plus 3 and x plus 1, which will give you 0. That will be x minus 2 is 0, and then x plus 3 is 0, or we have x plus 1 is 0. From this 3 equation, we're going to solve it. We're going to have x equals 2, x equals negative 3, and we have x equals negative 1. So that is your final answer. So our solution set is negative 3, negative 1, and 2. Okay? Example 4, we have similar questions. F of x equal to x cubed plus 7x squared plus 11x minus 3. Step 1. So step 1, we're going to find the possible rational zeros, positive 1, positive 3. In step 2, we're going to try use the synthetic division to find a 0. So I'm going to try 1. So we're going to have 1, 7. So that's where that comes from. 11, negative 3. So let's do this. We're going to have 1. That would be 1. This is 8. 8. That would be 19. Multiply. That would be 19. So this can give you 16. Because our first one, it didn't work. Okay. So this didn't work. That's why we had to continue to see until we could find a 0. So in this case, finally, we found this negative 3 is a 0 of the function. So once we have this, that will be implies our x plus 3 is a factor. So now we're going to rewrite this as x cubed plus 7x squared plus 11x minus 3 equal to 0. So we know this x plus 3 is a factor. And then here, from this part, we also get x squared plus 4x minus 1. That would be equal to 0. So once we write this, normally we would try to factor this second term, but if you look, we cannot actually factor it. So what I'm going to do is, I'm going to go ahead and set it to 0, x equal to 3 to 0, and then we're going to set x squared plus 4x minus 1 equal to 0. So we're going to solve for x squared plus 4x minus 1. So I'm going to go ahead and use a quadratic formula to solve this. It's going to have x equal to negative 2 plus or minus square root of 5. I'm going to write it right here, x equal to negative 2 plus or minus square root of 5. So our solution set is, that would be negative 3. Then we have negative 2 minus square root of 5, negative 2 plus square root of 5. Okay, example 5, solving a polynomial equation. Here we have to remember, we refer zeros of a polynomial function, and then we use the roots for polynomial equations. So let's take a look at this polynomial equation. Here we have all the possible rational roots right here. We wrote it really quickly. In this case, we're going to have a lot of them. We're going to use a graphing calculator. By using graphing calculator, we can actually find the first roots. Okay, let me explain this really quick. So in your graphing calculator, all you have to do is just enter the function x to the 4th power minus 6x squared minus 8x plus 24. So by using a graphing calculator, you can find this right here, okay? That will be wherever you intersect right here, your x-axis, that is your first root, which in this case is 2. So instead trying every single one of them by hand, we'll just use our graphing calculator to find our first root 2. So now we're going to use 2. So we're going to set this standard division up. So we're going to have 1. So since we're missing x cubed, so we're going to use 0. That would be 1, 0, negative 6, negative 8, and 24. So we're going to go ahead. We're going to get, here we have drop it down, then 2, add them, that will be 2, and then here multiplies to 4, add them negative 2, multiplies negative 4, add them, that will make it 12. Multiply, that will make it 24, and then you add them, give it 0. Alright, this shows us that in fact it is one of our 0 because here remainder is 0. So we know the first root is 2, so that implies that is x minus 2 is a factor. So we're going to rewrite this as x to the 4th power minus 6x squared minus 4x plus 24 equals 0. So we know that x minus 2 is a factor. Then we can use the results from the synthetic division to write it down. So you're going to have x cubed plus 2x minus 2, the 2x squared minus 2x minus 12 equals 0. It looks like we're stuck. However, you just learned how to do this type of question, right? So you just learned this previous, actually the previous example, we just done this. If we set this to 0, right? We're going to set this part to 0. X equals you 2. This is one of the roots. And now we're stuck right here. But all you have to do is just repeat the process we have done. Alright? So this graph comes from f of x equal to x cubed plus 2x squared minus 2x minus 12. If you enter this inside your graphing calculator, so we repeat the process. Now you have 2, then we know this is x minus 2 is a factor. So we do this again. We're using the 2. Now we're dealing with this part. That would be 1, 2, negative 2, and negative 12. So we use the synthetic division. So we're going to have a 6 right here, and then we did it correctly. It should be get 0 because from graphing calculator we saw this remainder should be 0. Again, this will give you constant. This is x, and this is x squared. So you're going to have x squared plus 4x and then plus 6 equals 0. So what I'm going to do is, in this case again, x minus 2 is 0, so x equals 2. They just repeat it. So then we're going to look at this. That would be x squared plus 4x plus 6 equals 0. Alright, so we're going to use x equal to negative b plus minus b squared minus 4ac over 2a. I'm going to find our answer. That would be negative 2 plus minus I squared root of 2. The solution, that would be 2, repeated twice. I have negative 2 minus I squared root of 2, and then I have negative 2 plus I squared root of 2. Okay, let's go back and look at this question really quick before I move on. So you start with example equation. So we're talking about roots. If you wanted to, we could list all of them. So some question will ask you this, list them. Once you have this, instead of trying every single one of them, so you'll just use your graphing calculator right there to find your first root, so which is 2. And then I'm going to use the synthetic division. So then we can factor it. Once we factor it, we realize we're still going to have x cubed. So we have to repeat the process by finding another root for this function. We use the graphing calculator again. We realize this is just another 2. So we use the synthetic division again. So now we can factor, and then we realize that will be x squared plus 4x plus 6. We cannot actually factor it. So we use the quadratic formula to find our x. So that will be your solution set. From this question, you actually realize a couple of things. So if a polynomial equation is a degree n, then counting multiple roots separately, the equation has n roots. For the previous question, we have x to the 4th power. So that means the degree is 4. We did have 4 roots, but 2 repeated twice. Okay, that's what that means. If the degree is n, they will have n roots. Another thing is, if a plus bi is a root, the a minus bi is also a root. That's really important. Let's look here, the linear factorization theorem. If we have a polynomial function, so if we have this, then we're going to say c1, c2 to cn is the complex number. You look at those, it's kind of difficult to relate. Let's go ahead and start with example 6, and then I'll show you how that works here. We're going to find the 1st degree polynomial function with real coefficient that has negative 2, 2, and the I as 0. And then such that f of 3 equals negative 150. from this question, we know a couple of things given to us. Our n, which is the degree of a polynomial, is the 4th degree. So that will be n is 4. N equals 4. That implies we have 4 roots. That's what tells us property of roots of polynomial equation. So we have a C1 is -2 because that's our zeros. We have C2 equal to 2. And then we also C3 equals I. And then we know there's another root, C4. And then we have used right here, the property tells us if A plus BI is a root, then A minus BI is also a root. In this case, when we have this here, as A plus BI form, in here, this case tells us our A is 0, right? So that means A minus BI also is a root. Since this is 0, this is going to be, I'm just going to write negative I is our C4. So now we're going to set it up. Because we want to find the function f of x, okay, we want to find our original function. So we're going to set this up by using the linear factorization theorem. So we're going to have f of x equal to a sub n. So we still don't know what's a sub n. I'm just going to write it down, the formula first, then I'll show you guys. That will minus c1, x minus c2, because of 4 roots, we're going to have c3, x minus c4. And then we'll just do a substitution. And then now we're just going to simplify a little bit because we have negative. Let's just get rid of those extra. This is what we get so far. So once we have here, we're going to continue to simplify. So here we have x plus 2, x minus 2, right? Multiplication. We're just going to have x squared minus 4, right? Then here we have x minus I multiply x plus I. That actually just going to give you x squared minus I squared. If you look at minus I squared, so now we're going to have x squared minus 4. So we realize there's going to be x squared plus 1, right? Because I squared just going to be negative 1. Negative become positive. So we want to expand this a little bit further. So we're going to have f of x equal to a sub n. So here, for this term, let's go ahead and do it on the right side. So we're going to use a FOIL method. So here we're going to have x to the 4th power plus x squared. Then we're going to have minus 4x squared, then minus 4. So simplify this, you're going to get x to the 4th power. That will be minus 3x squared. That will collect like terms. And then we're going to have minus 4. So we're going to rewrite this right here. That will be x to the 4th power minus 3x squared minus 4. Now we're going to go back here. We're going to use this piece of information because we know f of the 3 equal to, somehow we're going to equal to negative 150. Just like normally we evaluate f of a number, so we're just going to replace x with 3. That will be 3 to the 4th power minus 3 times 3 second power minus 4. Let me go ahead and just highlight this. So once we have here, we realize we can just find this is 50. That will be equal to negative 150. So when you try to solve this a sub n, you just divide 50 both sides. So that's going to be gone. They're going to have a sub n equal negative 3. So once we have here, you have to remember eventually your goal is to write the function. So what we're going to do is we're going to bring this a sub n to right here. Or do a substitution. We're going to have f of x equal to negative 3 multiply x to the 4th power minus 3x squared minus 4. So now we just do a distribution. We're going to have f of x equal to negative 3x to the 4th power plus 9x squared plus 12. That is your final answer. Let's go ahead take a look before we move on. Okay, when you have this type of question, okay, step 1 is you're going to need to figure out what's your n. If you have n equals to 4, that means you have 4 roots, which means you have to find your C1 to C4. So one thing you have to remember, if you have I as 0, that means your negative I also is 0. That's based on your property of roots. If I have this is 1 plus I as 0, then you're going to have 1 minus I is your C4. So once you have this, you're going to use your linear factorization theorem right here. I copied down right there. And then you just plug in your C1 to all the way to C4. And then you're going to do is you're going to expand all your function. Okay, we're going to expand all the way to here. Then you're going to use your another piece of information right here. You replace your x to the number f of 3. You replace your x, and then you find your a sub n. Once you find your a sub n, you go ahead to bring it back, do a substitution. Okay, back there. Then finally you find your function, you do a distribution, you finally find your function. That's how you do it. Okay, here is the homework questions. I'm not going to solve the whole thing. I want to just give you some hints, okay? You have n equals to 3. That implies you're going to have x minus c1, x minus c2. You're going to have x minus c3, okay? That means you have 3 roots. And then we said -2 is 0, so we're going to use this. Your -2 is minus the 0, and then also tells you a plus 4i is 0, x minus 8 plus 4i is 0. Then you have to remember that implies a minus 4i also is 0. That is how you set it up. And then you simplify this, okay? All this on this side. You're going to simplify this whole thing. You're eventually, in this case, you're going to have f of x equal to a sub n equal to x to the 3rd power minus 14x squared plus 48x plus 160. Here, let me give you some hints actually. Otherwise, you're probably going to take a longer time. So for this term, x plus 2, then you're going to have x minus 8 minus 4i. Then this term, you're going to have x minus 8 plus 4i. So once you have this, so treat this as your a, that's your a, and then this is your b. And then you're going to have a squared, that will be x minus 8 squared, then plus b squared plus 4 squared. So if you use this method, I find that it's much faster. If you want to do the follow method, somehow I think you're easy to get lost. It takes some time to use to it, but definitely you can do it. Once you have this, use your PC information, alright? Because f of 2 equal to 208, and then you just replace this 2 squared plus 48 multiplied by 2, your a sub n multiply to a equals 208. So you're going to have your an equals 1. Once you have 1, you'll bring it back right there. But in this case, it's just 1. That just, you didn't have to do the distribution. So that is your plus 160. Okay guys, so do some homework and then practice more. If you have questions, definitely ask me. So it's not easy. So ask me questions. I would love to help you. Thank you for watching the video. I'll see you guys next time.